Okay, hi, Assalamualaikum guys. Okay, so today we are going to learn about structures, okay? Okay, so there are about about 6, okay, 6 subtopics, around 5, okay, if we exclude the introduction, which are plane trusses, method of joints, method of sections, space trusses, and lastly is frames and machines. Okay, so today we are going to cover introduction and a little bit of method of joints. Okay. Okay, so now, okay, so in this chapter, we focus on the determination of the forces uh, internal to a structure. Okay. First, we have to study about force of action and reaction between the connected members. Okay. Okay, so how to determine this? First, we must dismember the structure, okay, and analyze separate free body diagrams, okay, of individual members. Okay. Okay, so these are the example of, okay, bridge trusses, okay, and then we have roof trusses, okay. Okay, then next is we are going to learn about plane trusses, okay. Okay, so a framework composed of members joined at their ends to form a rigid structure is called a truss. Okay. Uh, so we have bridge, roof supports, okay, which are the common examples of trusses. Okay. So, okay, when the members of the truss lie essentially in a single plane, okay, that is the truss that we call plane truss. Okay. Okay, and then okay, so okay, so I'm going to say this. Okay. So okay, so we just look at this picture. Okay. Okay. Okay, from okay. Okay, so this is bridge, okay, bridge trusses, okay. So now we have okay, weight of the roadway, okay, so there is road, okay, okay, and then there is vehicle, okay. So we combine these two weights, okay, these two loads, okay. So these loads are transferred to longitudinal stringes, okay. Okay, so this load is transferred onto the stringer, okay, and then it is transferred to the cross beam. Okay. Okay, and then lastly, the upper joints of two plane trusses. Okay. The vertical sides. Okay. And lastly, the load is transferred to the vertical side, okay, of the structure. So this will be the third one. Okay, 1, 2, and then lastly it will transfer into the vertical sides. Okay. Okay. Okay, so this is what I explained before. Okay, the combined weight of the road and vehicles transferred to the stringes and then to the cross beams and lastly to the vertical sides of structure. Okay, so next, simple trusses. Okay, so the basic element of a plain truss is the triangle. Okay, so where? Okay, so this is the triangle. Okay, so this is the triangle. Okay, so this is a rigid frame. Okay, I mean it is very rigid. Okay, it's not moving. Okay, rigid frame. Okay, which means it is non-collapsible. Impossible it is for it to collapse. Okay, and then other than that, 4 or more bars pin join to form a polygon. Okay, so this one it is non-rigid frame. Okay, it can be moved or it is possible to collapse. Okay, so this is the polygon. Okay, this is the polygon. Okay, so we can make the non-rigid frame, okay, in figure B to become rigid or stable by adding a diagonal bar. Okay, so this is the diagonal bar. Okay, so this is the diagonal bar. Okay, and then we also can add additional, adding additional units of 2N connected bars. Okay, so this one. Okay, this is the 2N connected bars. Okay, and then so structures built from a basic triangle. Okay, so we call this as simple trusses. Okay, but when more members are present then that is necessary, okay, to prevent collapse, we call it redundant. Okay, mean extra. Okay, and then to design a truss, we must first determine the force. Okay, so first we assume all members to be two force members. So for each member, okay, like this, okay, they have two forces. Okay, they have two forces here for each member. Okay, Okay, it is. It should be equal. Okay, where is it? Equal. Okay, so should be equal, opposite, and collinear for equilibrium. Okay, so should be equal, opposite, and collinear. Okay. Okay, so the force can be either outward, okay, like this, outward, or inward. Okay, so for outward, we call this as tension. So meaning that the member here is in tension. Okay, and then for force that is coming inward, we call it the member is under compression. It is being compressed. The member is being compressed. Okay. Okay. And then next, we go for truss connections and supports. Okay, when welded or rivet connections are used to join structural members, okay, we assume that the connection is a pin joint. Okay, and then we also assume that all external forces are applied at the pin connections. Okay. Next, two methods for the force analysis of simple trusses will be given. Okay, so there are two methods which are the first one is method of joints. Okay, and second one is method of sections. Okay, so first the free body diagram. We draw the free body diagram. Okay, and then the external reactions are usually determined first. Okay, so this is first free body diagram, and then we determine the external reactions. Okay, and then by applying the equilibrium equations to the truss as a whole. Okay, and then force analysis of the remainder of the truss is performed. Okay, so this is the third step. Okay. Okay, so now we are going to learn about method of joints. Okay. So this is, we should refer from this one. Okay, so we are going to analyze this structure. Okay, so this is the free body diagram. Okay. Okay, so we begin the analysis with any joint where at least one known load exists. Okay, and not more than two unknown forces. Okay, if more than two, then it is difficult to determine the force. Okay, the unknown force. Okay, and then the solution. Okay, we may start with the pin at the left end. Okay, so here so we have R1. Okay, we have which color I want to use? Okay, this one. Okay, so we have here, right? We have choice to do either here or here. Okay, so here we know the load, and we have two unknown force here and two unknown force here as well. Okay, and then we can choose from the left. Okay, so we go for the left one. Okay, and then okay, so to make for us not to confuse two letters defining, I should be define the end member. Okay, so in this case here we just put AF AB. Okay, so AF here. Okay, AF and AB. So based on, we name it based on the joint. Okay. Okay, so in this case, okay, so here we know that okay, this one, okay, the load is going upward, isn't it? Okay, and then so we have like, okay, I think I should draw the new one. Okay, this one, okay, this one we have load R1. Okay, and then we don't know for this one. Okay, for the member of AF and AB, right? Okay, so what we should do is we just look at the R1. Okay, so it is going upward, right? So this one should be the component should have downward, so it will be moving like this. Okay, and then so there is another component of X going to the left, so this one should encounter it by going to the right. Okay, okay, so that's it. Okay, 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 and then after we settle joint A, okay, joint A we settle, right? Okay, joint A is done, and then joint F is next. Okay, we should analyze the next one that we should analyze. Okay, so we just go to figure 4.8. Okay, this shows the free body diagram of each joint. Okay, so we have a look at this one. Okay, okay. So I have to use this picture. Okay, okay, so here so first we analyze the joint A, right, previously. Okay, so we know that this one is, let's see this one. Okay, this going this way, right? Okay, and then we have this one going to the right. Okay, and then what we do is next, okay, A is done. Okay, A is done, and then we go for joint F. Okay, joint F is the second one. Okay, okay, and then so we know here we have A here, so this one should be opposite. Okay, because we say that this one is in, we call this intention, right? Okay, so in any case the direction should be opposite. Okay, if this is going downward, this one going upward. Okay, so okay, and then for F, okay, so we have this one, we don't know this one, right? Okay, so now what we are going to do is, okay, so we just draw the component first. Okay, so this is to the right, and then this is going upward. So we must encounter by downward forces. So this one should be downward. Okay, and then this one going to the right. So this one should be going to the left. Okay, and then we go for next join, okay, which is B. Okay, the third one is join B. Okay, so we know this one AB, so this one should be different direction, and this one also this one different direction. Okay. Okay, so now we have two, what we call this, two unknown. Okay, two unknown forces. We don't know this one and this one. Okay, so we have what is this? Okay, this one left. Okay, and then this one should be to the right. Okay. Okay, so for this one, according to the book, it is going upward. Okay, so since we don't know, okay, I just KIV here. Okay, so next is, for me, I prefer to go join D. Okay, join D as the fourth. Okay, join D is number 4. Okay, so because there are two unknowns, and okay, then okay, so we have, don't forget, we have load R2 here, right? Okay, okay, and then if you're not sure, let's just take a look. Previously, where's the picture? Okay, here, remember? Okay, so this is going upward, so there must be downward. So this one should be downward, okay, and this one will automatically for force axis going to the right. So this one should be going to the left. Okay. Okay, so next we go for the fifth join. Okay, so I go for number 4. Okay, I go for join C. Okay, so this is the fifth join. Okay, C. Okay, so for C, I'm using what color? Okay, this one color. So we know this. Okay, so this is going to be to the right, and this one going to be to the left. Okay, so check. Okay, it's correct. Okay, so there should be no forces here. Okay, so y is 0. Okay, so CE is 0. Okay, because there is no forces in y direction. Okay. And then we are going for the sixth join. Okay, so this one is the sixth join E. Okay, so let's join E. So this one we know. Okay, this one KIV. This one is 0. So this one should be look like this. Okay, so we have outward. So there should be, there is outward, right? Outward component. So there must be downward component. Okay, so this one should be like this. Okay, so here should be like this. Okay, so correct as what the book has point out to us. Okay, okay, so done. Okay, that's how we are going to analyze using method of joins. Okay. Okay, so this is just reminder. Okay, sometimes we cannot initially assign the correct direction. Okay, so we may assume, we can make assumption. Okay, a negative negative computed force value indicates that the direction is incorrected. Okay. Okay, now we go for internal and external redundancy. Okay. If a plane truss has more external supports than are necessary, okay, this is what we call external redundancy. Okay, if it has more internal members than that are necessary, we call it internal redundancy. Okay, and then this is the special conditions. Okay. Okay, when two colony members are under compression, it is necessary to add a third member to maintain the alignment of the two members. Okay, prevent buckling. Okay. Okay. If n external force, if a component in y direction, okay, so okay, so this is okay, cancel this one. Okay, so this is the what is this, what we call it earlier, two collinear members. Okay, so two collinear members. Okay, this is two collinear. Okay, 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 so for summation forces at y-axis to be equal to 0, F3 must be equal to 0. Okay, and then for summation of Fx equal to 0, F1 should be equal to F2. Okay, and then when two non-collinear members are joined, okay, the forces in both members must be 0. Okay, so for this case, we have two non-collinear members. Okay, so this is two non-collinear members. Okay, so here is summation of Fx equal to 0. So this F1 should be equal to 0. Okay, and then for summation of Fx prime equal to 0, so F2 it should be equal to 0. Okay, so this one should be equal to 0. Okay, and then lastly is when two pairs of colony members are joined. Okay, forces in each pair must be equal and opposite. Okay, so this one is two pairs of colony members. Okay, 2 pairs, 2 units, okay, 2 pairs of collinear member, okay. So the force should be equal, F1 should be equal to F2, okay. So for summation of Fs equal to 0, okay. And then F3 should be equal to F4 if summation of Fx prime equal to 0. Okay. Okay. Usually trans are cross braces. Okay, like this one. This cross braces. Okay. So usually we should determine either the cross brace can support is useful or not. Is it necessary or not? Okay, so how we are going to do that? We just do the asymmetry, put some asymmetry loading. Okay, and then okay, so we put asymmetry loading. Okay, and then we see how the panel will deflect. Okay, so let's say here we put some load. Okay, and then we see that DC is reflected. Okay, this one is reflected. Okay, so therefore member of CD should be disregarded. So we don't need CD. Okay. Okay. So and then okay, so this one. Okay, we can avoid simultaneous solution of equilibrium equations. Okay, by carefully choose the right reference axis. Okay, so in this case, if we use let's see this one. Okay, so let's say we use okay this one as the axis. Okay, so here okay, so in this case this one no this one. Okay, so L is we know. Okay, the value is L. F1 we don't know the value of the force. Okay, so in this case we just okay, so we just write out the component of L. Okay, so okay, so L we have in this way, in this way. Okay, F1 is in this way. Okay, so F2 is in this way. Okay, so this is the component. So here, this one is we know. This one we don't know. We don't know. So there are 3 unknowns. Okay. Okay, so you also can use this type another axis, which is okay, which is in this direction. Okay, can also, but we are not supposed to use normal axis in this case. Why? Okay, now so let's say if we use normal axis, okay, Normal exist mean like, okay, like this one. Okay, so let's say you take the normal exist. So what happen is, okay, we have to break down the component again. So L, we have here L, okay, and then for this one, it is becoming into this way and this way, right? Okay. Okay, upward and to the left. Okay, this one downward and to the left. To the left. Okay. So here we know. We don't know. We don't know the value. We don't know the value. So we have four unknowns. Okay, so that's four. Choose wisely the reference of exist. Okay. So we are going to continue for the example later. Okay, so that's it for right now. Okay, so stop share and then stop record. Okay, thank you for your times.